The City of Yonkers court-imposed fine structure. Judge Sand imposed a fine against the city that started at $100 on August 2nd and doubled every day thereafter until officials obeyed the court order. Our job is to find a function that models the relationship between the number of days since August 2nd and the fine imposed upon the city. To do this, we'll complete the table and look for a pattern. So on day 0, the fine is $100. On day 1, the fine doubles and is $200. On day 2, the fine doubles again to $400. Day 3, it doubles again to $800, and so on and so forth. So if this relationship is linear, we know that the difference in successive outputs will be constant. So for example, for this first pair of successive outputs, we have 200 minus 100 equals $100. And for the next pair, we have 400 minus 200 equals $200. And we can stop there because $100 is not equal to $200, so the relationship is not linear. So, in order to find a model for the relationship, let's complete the rest of the table. Day 0, the fine was $100. So on day 1, we take the previous day's fine, which is $100, and to double it, we multiply by 2. On day 2, we take the previous day's fine, which is $100 times 2, and we double it by multiplying by 2 again. On day 3, we take the previous day's fine, which is $100 times 2 times 2, and we double it by multiplying by 2 again. So I see a pattern here. On day 3, the fine is $100 times 2 cubed. And on day 2, the fine is $100 times 2 squared. And on day 1, the fine is $100 times 2 to the first power. So on day 0, the pattern should continue, and the fine should be $100 times 2 to the 0. And since 2 to the 0 is 1, the fine is indeed $100. If we let t equal the number of days since August 2nd, and we let y equal the fine in dollars, then the relationship between the number of days since August 2nd and the fine can be modeled by the function y equals $100 times 2 to the t, where t is the number of days since August 2nd. This is an exponential function, and we'll chat more about exponential functions when we return to the lesson. But for now, I want to show you how we can use the table of data to recognize when the relationship between the input values and the output values is exponential. When a function is represented in a table of data where the inputs increase by a constant amount, we can look at the successive outputs and determine whether the function is linear or exponential. We know that if the difference of successive outputs is constant, then the function is linear. But if the ratio of successive outputs is constant, then the function is exponential. For example, looking at this first pair of successive outputs, the ratio is 200 divided by 100, which is 2. The next pair of successive outputs gives us 400 divided by 200, which is also 2. And the last pair in the table is 800 divided by 400, again 2. Now you may be thinking, well, of course the ratio of successive outputs is constant, and it's 2, because we multiplied by 2 each time to figure out what the next day's fine would be. In fact, if the inputs increase by 1, then the ratio of successive outputs is the base of the exponential function, and that's called the growth factor. And the base is called the growth factor because we multiply by the growth factor each time to get the next output value for the function. Bye for now.